Hi everyone, welcome to Unit 2. In this unit, you're going to be learning about using objects. Objects are a class of data types that are more complex than the primitive data types that you used in the first unit. That means that we're actually going to be able to use them to represent real-world objects. There's one object that you've actually already seen, one class data type that you've worked with, which is called string. You've worked with strings already, and we're going to use that to introduce and to start working with objects in this lesson. So in this lesson, you'll learn about the differences between class data types and primitive data types. You'll learn about this keyword null that is used to represent an object or a class data type that we haven't actually created yet. And you'll get a chance to think about how class data types are stored in memory. Java has two basic kinds of data types. The first kind of data type is the primitive. So in the first unit, we focused mainly on primitive data types. Those are ints, doubles, and booleans. There are other primitive data types in Java, but for this class, you only need to know those three. And the key feature of a primitive data type is that they hold only one piece of data at a time. Like an int holds only one whole number, a double holds one number with a decimal component, and a boolean holds one true or false value. Now, in contrast, in this unit, we're going to be focused on class data types, also called reference data types. And these data types hold more than one piece of data at a time. So the one example that you've already seen is the string data type. Now, a string data type, you might think of that as just one piece of data, but remember that what it's actually holding is a set of letters, a set of characters that make up that string. So that's multiple pieces of data. And class data types, that's a pretty basic example. There are lots of really complex data types that can hold varied and large amounts of data. So they can hold data of different types. They can hold an int and a double and a string. You know, for example, there might be like a person data type that holds their name and their age, all part of the same data type. The other thing about class data types is that they have built-in methods that you can use, like tools that you can use to work with and manipulate that data. And you're going to be seeing lots of the different string methods later on in this unit. And then later on, even further in this class, you're going to have a chance to create your own classes, create your own class data types. Because this is fundamental to understanding how Java as a programming language was built. At some point, every class data type that you use had to be built by some programmer. And that's basically how Java was built up to be the complex language that it is today. Let's think a little bit about how data types are stored in memory. Now, I briefly touched on this in Unit 1, but I want to go back to it to revisit it in more detail. Primitive data types, when you declare an int, are stored as the actual value. So that means that when you declare an int called num1 and set it equal to 17, there are actually binary switches, little zeros or ones in the computer, that flip to either 0 or a 1, and they form the number 17 in binary. So if you've had a chance to study the binary number system, you know exactly what that set of zeros and ones would look like, and somewhere in your computer that is stored, and that's what this variable num1 refers to. Class data types, instead of storing the actual value, what they're actually storing is just a memory location. They're storing a memory address that points to the place where that information is stored. So if we think about these two lines of code, the first line is going to create a variable a, and it's going to point to a memory location where we're going to store the word what. All right, and then once we create another variable, this variable, b, is declared equal to a. And so what it's actually going to have is it's going to store a memory address that it points to this word. So in other words, instead of them both being copies of the word what, they're actually both copies of this memory address, right? You can think of this memory location as having like a zip code. And that's what these two variables are storing, is the zip code that leads you to the place where the word is stored in memory. So we're going to see a couple of impacts of this concept going forward with the rest of the lesson. But for now, I just want you to keep this in mind and try to read through the summary to check your understanding for how class data types are stored in memory.